Hello everyone, welcome back. In this video we're going to be taking our Mercury SR2 and we're going to be using a vectored thrust model, or we're going to be programming up a vectored thrust model. So this video will cover off a vectored thrust application. So we're going to take you through the setting up and also assigning the outputs, gyro, you name it, we'll set it up. Okay. First things first. Now, one thing to get in your heads is when you're programming up a Mercury, if you have a vectored thrust attachment, or say you want to set up ailerons or a Delta aircraft, basically an aircraft where you need to do some mixing, so traditionally you do it in your transmitter, you still need to do that in your transmitter. So the Mercury, the competition, as well as the Royal SR2, there's no real mixing done in those. Basically, those PowerBoxes, what they do is they take the raw output from your radio, whether it's mixed or not, and they assign it to their respective outputs that you program, and then they also assign the gyro. So really what they do is really control the gyro and its impact on the relevant output that you assign it to. However, when it comes to mixing, so for instance, in this case, the vectored thrust nozzle is normally controlled by yaw and pitch inputs. That's not done inside the Mercury. It's actually done by the core transmitter or the atom transmitter. So your first step before you program the PowerBox is you've got to make sure that your actual vectored thrust movement is actually set up in the radio. So you've got to set that up first. So we're going to do that. Okay, what do we need to do that? It's pretty basic. Let's go into our functions menu. And we'll still use the same aircraft I've been using in all the Mercury SR2 videos. We have a throttle, I can't remember if I moved it, but basically assigned to channel 11. We're not using that, so that's sort of neither here nor there. Ailerons are using channels 1 and 2, elevator 5 and 6. 3 and 4 are for our flaps, which I haven't shown on here, because basically flaps aren't really used in this application. Well, what I'm saying is the flaps are not basically driven by the Mercury as such. We still have them on the aircraft, but I haven't bothered to program them. We have a rudder. So the rudder's on channel 7. And then we have our gyro gain on channel 10. Our capacity reset channel 16. Now don't forget, these two servo channels for gyro gain and capacity reset, they don't actually have to fall in the actual numbering scheme for your Mercury or your competition, for instance. So you remember the Mercury can do up to 16 PWM ports. However, we can assign this to say channel 26, which is basically a virtual channel, and we can assign gyro gain to, channel 18, whatever. It doesn't have to be between 1 and 16 as far as the Mercury is concerned. It'll still use that particular channel because we're not actually using these to drive the servos, we're just using it to activate a particular feature which is inside the Mercury. And the Mercury has access to all our 26 channels. Quick moving on, sequencer we're not using in this application. Now, I did mention this in the other two videos. I do have a vectored thrust pitch and yaw function. However, I haven't assigned any control stick movement at this point in time, but I have assigned the pitch to channel 8 and the yaw control to servo channel 9. So we're going to use channels 8 and 9 basically to control the two servos for pitch and yaw control. Now, first up, remember I said you have to set up the mixing within the actual transmitter. Whether it's ailerons or whether it's vectored thrust as per this example, or even a Delta aircraft, you have to set up that particular mixing in the transmitter before you set up the PowerBox unit. So, for pitch, normally we use our elevator stick. So basically our pitch controls our pitch, nose up, nose down, or tail up, tail down, depending which side of the fence you sit on. So we program stick C on my mode 2 pilot. So stick C, which is also my elevator stick, is controlling servo, or channel 8 I should say, so the servo that's plugged into channel 8. However, being in the elevator function, it's also controlling servos 5 and 6, which are our two elevator servos. So just bear that in mind. And same with the yaw control. So I'm going to use my rudder stick. So if I move my rudder stick, stick B, we have now the rudder stick controlling servo number 9 as well. And you might be, I haven't got the servos pictured at the moment, but you can probably hear them moving. Now at the moment, my PowerBox unit is, or has been factory reset to default. So all it's doing is passing the channels straight through to the servos. So basically, port 1 through to 16 is just passing through channels 1 through to 16 to the servos. So all I've done is plugged in these servos into those respective ports. Later on, when we go through the setup assistant to define the actual vectored thrust setup in the actual Mercury, it'll basically give us a default port assignment, and we can move the servos to those ports, or like I've shown you in the previous video, you can reassign those ports as you see fit. Probably for this video, I'll just move the servos around because that's just easy to do. Saves less video time. So don't forget, the vectored thrust pitch and yaw feature has to be, or basically the mixing has to be done in the radio. So at the moment, just by setting those two functions and assigning the sticks, basically the mixing's done. There's no, being a core and atom radio, just by using this function input, there is no mixing program, or you don't have to go into a dedicated mixer function to achieve that, which is a very good benefit of these radios, or basically the programming within these radios. All right, so once we've done that, I might just go to our Servo Monitor screen, and we can see all our servos here, or most of them I should say. So we've got aileron left and right, so if I move my aileron stick you can see those move. We've got channels 3 and 4, which are my flap servos, but I haven't programmed these in, mainly because we haven't been using them in these videos. Elevator left and right, so if I move my elevator stick up and down, you'll see the elevators move. However, if you look carefully, if you look at channel number 8, which is our vectored thrust pitch control, that's also moving as well. Because don't forget, our elevator stick is also controlling the vectored thrust in the pitch plane, I should say. Okay, rudder. So rudder servo channel 7, you can see channel 7 there, and if you look just below it, channel 9, which is our yaw output, you'll notice both of them are moving. So I'm just moving my rudder stick there, try not to bump the radio too much. And you'll see both are moving. Oops, I bumped the throttle. And of course you can go into the servo screen and adjust the servo centers, travel adjustment as you see fit. But the major thing to take from this part of the video is the fact that the mixing has to be done in the radio. So you need to set up, if you're flying a core or an atom, you need to set up the vectored thrust functions like I've just shown you how to do. If you're using, say, a Fataba or another radio, you probably have to go into a separate mixing menu to achieve the same thing. Okay, now let's go back to the home screen, and I might just show you the two servos so we have an idea of what we're looking at when we move the sticks. And then after that, we'll move back to the Mercury screen, the little OLED screen here, and we'll step through the setup assistant, which will basically set everything up for us. So you'll see how easy it is to do when we use a setup assistant. Okay, so let's shift over to the servos. So now we can have a look at our little Servo Test Bed. So this is the same test bed I've been using in previous videos. I've just zoomed into these two new additional servos which I've added. So we've got a rudder servo here in the middle. We've also got two elevator servos for a split elevator control. Just above those, sort of out of the picture, I've got two flap servos, and above those are some aileron servos. However, we're not really interested in those servos for this video. We're really interested in the elevator and the rudder, as well as the thrust nozzle servo. So here's our pitch servo. So this servo will control the pitch of the thrust vectored nozzle, and same goes for the yaw control for the nozzle. This is a servo that will control the basically the yaw axis as far as the thrust vectoring nozzle is concerned. Now, at the moment, all I've done is plug these servos straight into the Mercury in the corresponding channel assignments. So basically these were plugged into channels 8 and 9, rudders in 7, elevator here's in channel 5, and this one here's in channel 6. Later on when we go through the setup assistant, it'll have its own preference of ports, so we'll reconfigure the servo leads to plug into the corresponding ports that the Mercury wants us to plug them into, and we'll move on from there. And remember, if you watched the last video, you can reassign those ports as you see fit. Okay, pitch and yaw. So now remember we added those two functions in the radio. So in the transmitter, basically the thrust vectoring is already set up for us just by adding those two functions. So I just want to explain to you how it all works. If I move my, say, rudder stick, you'll notice the rudder itself, or the rudder servo, is moving, and also the yaw servo. Because remember we set up the function, the yaw function, vectored thrust yaw function, and we set up the stick to control not only the rudder servo but also the yaw servo. So that's what's happening here. Now I've got these working in the same direction because you know, if you're sitting in the aircraft, for instance, and if we give it a right rudder, so if I move my rudder stick over to the far right, I want both servos to indicate a right movement, indicating the rudders move to the right, physically move to the right, and the yaw axis on the thrust nozzle, on the vectored thrust nozzle, has also made the nozzle move to the right. So if you're looking at the rear of the aircraft, the nozzle is basically moved over to the right. So basically that'll push the nose to the right, or the aircraft nose to the right, and the tail to the left, if that makes sense. So later on when we add the gyro, we just got to keep this in mind so we can basically identify whether the thrust nozzle is correcting in the right direction when we move the aircraft around. So basically the gyro's got to put in the opposite input to the actual movement of the aircraft. Okay, so that's the yaw function. Fairly easy to remember because basically it's just got to move the same way as the rudder servo. Cool. All right, let's have a look at the pitch servo. Now let's have a closer look at the pitch servo. So we've got the two elevator servos, and remember the pitch control is handled also by our elevator stick. So let's put in, say, let's pull on the sticks. I'm going to pull on my elevator stick, and you'll notice the two elevator servos will move up, and the pitch servo will also move up. So it's important this is correct at this point in time. So basically what I'm showing you there is as we feed in up elevator, the nozzle, the vectored thrust nozzle, also has to point upwards. So by pointing up, it pushes the tail down, no different to up elevator input, and that'll pitch the nose basically upwards. So tail goes down, nose goes up, as far as the vectored thrust is concerned. And obviously if we go the other way, so I'm putting in forward elevator movement on my stick, and that's putting in down elevator command on the two servos. So you imagine the elevator, the actual flight surface is moving downwards, and the tail is going to physically move up. So also with the thrust vectoring nozzle, to get the tail to move up, the thrust nozzle, or the vectored thrust nozzle, has to be pointing downwards relative to the tail's positioning for it to push the tail up. And basically when it pushes the tail up, nose goes down. So it's important just to remember that the pitch and yaw servos need to move in the same direction as relative to their inputs. So, well, basically their corresponding inputs, say with rudder and elevator, the pitch servo moves the same direction as the elevator servos for this example, and same with the rudder, the yaw servo. Yaw servo for the thrust vectored nozzle has to move the same way as the rudder for this particular example. Obviously, depending on your layout and your aircraft, they might have to be reversed, but basically we're just looking at these two servos relative to the actual throttle, the vectored thrust nozzle movement, if that makes sense. So just to keep it easy, this guy here has to move in the same direction as these two, and the yaw servo has to move the same as the rudder servo. So later on when we add the gyro, if we see the servos reacting in the same way, and I'll step through that anyway, we can assume it's all correct. Okay, I might just switch back to the OLED screen for the PowerBox, and we'll step through the assistant. Okay, back to viewing the two screens again. Just before we enter the setup assistant, I just want to quickly reiterate the functions, and in particular I want to have this function screen up so we can look at the actual channels used for the various functions. So we're not really concerned too much about the aileron. However, the elevators on 5 and 6, and remember the even servo, or the right hand side servo, is tied to the even channel. So channel 6 is the right hand servo. If I go in and have a look, we've got elevator right is the even servo, or channel 6, and channel 5 has the left hand servo. So I've maintained that throughout the whole setup. So basically even is on the right hand side of the aircraft, odd channel servos on the left hand side of the aircraft, so that's the same for the aileron and elevator. Rudder, we're just using the one servo, so that doesn't matter. We've got an overall gyro gain channel on channel 10. Capacity reset sequencer we're not too worried about. Then we come down to our pitch and yaw for the vectored thrust nozzle. So for pitch we've got channel 8 and yaw is on channel 9. So when we go through the setup assistant, we'll need to keep those numbers in mind. Now, one other thing before we start the setup assistant, there's actually another gyro gain required for specific just for the actual vectored thrust nozzle. So you need to add another channel to control the gain for the vectored thrust nozzle. So let's call that, say, VT for vectored thrust. And I'll just put the name or the words, or the word I should say, gain in there. So we've got vectored thrust gain, and I'm using my right rotary encoder ROB for the overall gyro gain. And let's use the left one for our vectored thrust gain for this example. Of course you can assign it to a switch if you like. And let's pick a channel. So let's use channel 26. So I'm going to use the very last channel of my core, and I might just call that VT gain. So this is the name of the actual channel if you like, because this naming appears throughout the programming in the core and also on the servo. Let's change the gain here. I was going to say, the name appears also on the servo monitor screen. So let's have a really quick look at that. So you see channel 26 VT gain. Let's go back to the servo screen. Now typically, again, depending if you're running attitude assist or not, you want negative or positive. However, for this example, I'm not really concerned about it. I'm just going to set it to plus minus 100. So when I move the rotary encoder, one way I've got positive gain, other side negative. Let's go back, have a look at it. There you go, channel 26. So when we go through the setup assistant, it's going to ask us to actually move the control. So we'll move the rotary encoder, and you'll see channel 26 will appear on the OLED screen for the gain for the vectored thrust nozzle. Okay, let's go into the actual Mercury. Now remember I told you I had that reset, so there's no programming in the Mercury at the moment. It's just got the default settings for the ports being direct. In other words, the information from the transmitters pass straight through channels 1 to 16 on the PWM channels or ports. Let's go to the setup assistant. Here we are. Let's select vectored thrust to be yes, because we're going to be using vectored thrust for this aircraft. Now, once we've done, oops, I'm pushing the wrong button again, aren't I? Let's go to next. Now you should be familiar with this if you watched my previous videos. So we're using the same basic setup again. So ailerons, we've got the two functions. We've got a left and right aileron function, and there's only one servo per function. So we've got a 2x1. Same goes for the elevator, so we don't need to change that. The rudder, we've just got the one function with the one servo, so that can stay as it is. Let's go to next. And this is where we move our sticks so the Mercury can detect the actual channels used. So remember aileron, if I move my aileron stick, you'll notice it now populates aileron right with channel 1 and aileron left with channel 2. However, if we look at our ailerons, remember aileron here, we're using channels 1 and 2, so that's correct. However, if we have a closer look at the actual allocation of the servos, aileron right needs to be servo 2. So remember the even channels are on the right hand side of the aircraft. So this screen is backwards, so we need to change that. So I just need to move my aileron stick again. Go the other way. And you'll notice the numbers or the two channels toggle around, so you can toggle these as many times as you like until the correct selection is presented on the screen. Once you're happy, hit next. And here's something slightly different from the previous videos insofar as on the OLED screen here we've got three parameters now. We've got elevator right, elevator left and vectored thrust pitch control. So remember our elevator is using channels 5 and 6. And remember channel 6 is the elevator right, being the even numbered channel. And elevator left is 5. And our pitch down here, vector thrust pitch, is on channel 8. So we need to select elevator right to be channel 6, elevator left to be channel 5 and vector thrust pitch to be 8. So all we need to do is move the elevator stick. Remember the elevator stick is controlling the three channels, 5, 6 and 8. So as soon as I move my elevator stick, you'll see some numbers appear on the screen on the OLED screen. So if I'll just bump the transmitter, make that roughly straight again. Let's move the elevator stick. You can probably hear the servos move. So what do we have here? We've got channel 5 and elevator right, elevator left is 6. So really those two need to be around the other way. The vectored thrust is correct. However, we don't like that assignment. We need to change it. So really we need to read 6, 5 and 8. So let's move the stick again. Oops, I bumped the stick. You've got to be careful when you move the sticks. So I put in a little bit of aileron input then, and it picked up more than 3 channels changing. So I just got to be careful when I move the stick. So let's try again. I go the other way. And we've got 6, 8 and 5 there, so that's still not quite right. So pitch needs to be 8 and elevator left needs to be 5. So let's move the stick again. Now we've got 8, 5 and 6, which is wrong. So let's move the stick again to give us another option. So basically the radio is basically moving through the options. Okay, 6, 5 and 8. That's what we need. Channel 6 is elevator right, channel 5 is elevator left, and channel 8 is vectored thrust pitch control. Let's move over to the next menu item, or the next screen. Rudder and yaw. So remember rudder is channel 7, and our yaw control, if I move the screen up a little bit. So rudder is channel 7, yaw is channel 9. So if I move the rudder stick, it'll control both channel 9 and 7, so we should see those two numbers appear on the screen. And they're in the correct assignment. 7 is rudder and yaw control is channel 9, so I'm happy with that. Let's move over to next screen. Now, notice it says move the master gain control. So the master gain control is my right rotary knob, so this gyro gain here is assigned to channel 10. So when I move my right ROB control, which is the right hand rotary encoder, we should see channel 10 appear on the OLED screen. And there you go. Just move the knob backwards and forwards a little bit. And now let's move over to the next screen. So now it's asking us for the actual separate vectored gain control. So remember we mapped or basically added an extra function specific to adjusting the gain for the vectored thrust nozzle. So we put that on rotary encoder A. Obviously you can put it on a switch, or you can have a fixed value. Or in this case, I've just got the rotary encoder so we can vary it. And remember, that's on channel 26. So remember, we've only got 16 ports on the Mercury. However, we're going to be using channel 26 because channel 26 is not going to appear on the ports on the front of the Mercury. It's just used internally. So you can use any of the channels that your transmitter can output. Obviously, if you have an Atom, you can only output 18 channels, but with the core, you've got the full complement of 26. So let me move my little rotary control, and you'll notice 26 appears on the little OLED screen. And the next step is to set up the gyro as far as the throws are concerned, and as well as its mounting orientation. So I might just move to, before I hit next, I might just move to a slightly different view so we can have a bit of a look at the aircraft as well. Stand by. Okay, so I'm not going to show you my little aircraft. I'm going to use a sensor on its own, basically because I wanted to picture this on the screen, close to the screen, have a good visibility of the OLED screen. So remember, the vectored thrust is being adjusted, or the gain for the vectored thrust nozzle is being adjusted on channel 26. The gain for the gyro gains for the normal flight surfaces is channel 10, so that's on a separate control. Okay, let's teach the gyro. So when we move on through the assistant, we activate or hit the next button again. And just to remember, this is the front of the aircraft, so it'll ask us to basically move the tail up and down. So I'll be doing this. So that's up, tail down. So tail up, tail down. Actually, I might do it in the air, might be easier. And I'll try not to wobble it too much, because if I do wobble it too much, it'll teach it incorrectly. It's a bit tricky when you're holding it in your fingers like this, but we'll see how we go. Okay, let's hit next. So you can see it says move tail up and down. So you'll hear the servos moving, and then I'll hold it up. So holding the tail up, just hold it up high enough. There you go. And then move the tail left and right. So basically I can rotate it left and right, or yaw it left and right, and then hold it right. And that's the mounting position teached. Hopefully that's learnt it correctly. I think that worked okay. We'll test it in a second. Now, it's important that we now have to teach the sticks. So what this does is basically teach the maximum throw. So when you get to this section, you got to make sure that none of your dual rates are activated. You do not want dual rates activated when you're actually teaching the stick positions. You must teach the gyro with the maximum throw that your servos are capable, or your servos and your linkages. So always remember to disable any dual rates when you're teaching the gyro. And that's specific to the teaching of the sticks. Okay, so it's pretty easy. Hold the aileron stick to the right, so I hold it full right. I'm holding it there, then I hit the button on my on-off switch. And then left. So that's taught the aileron left and right maximum throws. And we do the same for the elevator, so pull the elevator down, push the elevator up, or push the elevator stick up, so basically down elevator. Press the set button, let it go, and we do the same for the rudder. So this is teaching the gyro the maximum throw, and also the direction. When you want, say, left rudder, it then knows which way left rudder is, or right aileron, or up and down elevator. So it's important to get that right. Okay, as you can see, we're back to the setup screen, and that's pretty much done and dusted as far as teaching is concerned. The only thing to be aware of is the output mapping has changed. So it now uses the default output mapping screens. So for instance, if we have a look inside here, you'll see, if I just select the output and go back to output A. Output A is aileron right using the gyro function. Output B, so that's port B on the Mercury's PWM outputs. We've got the elevator right servo, should be plugged in there. Rudder in port C. And you'll notice we've got a couple of entries now pertaining to the vectored thrust nozzle. So we've got vectored thrust, the pitch servo, that has to be plugged into port D for delta. Then ports E F, G, H, I, J, K, L and M are direct channels. So basically those channels go straight from the transmitter straight to the PWM ports with no modification. And then port N, or output N on the Mercury, is where you plug in your yaw servo for the vectored thrust nozzle. And O is elevator left and P is aileron left. So that should be self-explanatory, and you should be well familiar that with the previous videos, so I've covered that output mapping function. And of course you can change them if you want. I'm just not going to bother for this video. I'll just go back to the exit the screen. So basically ready to fly, but before we do, we need to check to make sure the gyro orientation is working correctly. So let's move back to our model now, and let's have a look at the actual servos. And in particular, we're going to be looking at the yaw and pitch and elevator servos and rudder servo. So now we can see our relevant servos. So we've got our elevator servos and also the pitch servo moving. So remember, we're operating the pitch, vectored thrust pitch, off the same elevator stick, and they should be moving in the same direction as we discussed earlier. And same goes for rudder. So if I move my rudder stick to the right, left, you've got the yaw and rudder servos moving in unison. Okay, at the moment I don't have any gyro gains selected, so I can toss the sensor around and there's no movement. One thing I have done is I've activated attitude assist for all the axes, so we can see the relevant movement a lot easier. And let's dial in some gain, but only for the main flight surfaces. So that'll be for our two elevators. The ailerons aren't pictured in this view, obviously. So we're going to have a gain for rudder and elevator and ailerons. So I'm just going to move the knob for that. And let's dial up, say, I don't know, about 30% gain. Let's see if they move in the right direction. So hopefully the gyro taught itself correctly. Like I said, it's very you've got to be very careful when you teach the gyro, especially if you're just holding the sensor in your fingers like I was doing. It's very easy for the gyro to pick up incorrect movement, and you'll find after you go through the teaching phase it doesn't quite work 100%. So when you're teaching the gyro, take extra care, and if it doesn't work out right, just do it again. You can go into the gyro menu and just teach the gyro. You don't have to go through the whole setup assistant as such. Okay, now you can see the servo's wobbling a bit. So let's try the yaw axis first. So I'm going to rotate the sensor anti-clockwise. So I'm going to rotate it to my left. And therefore, we should have a right rudder correction input. So the rudder should move over to the right. Now remember, I've got gain set up just for my primary flight surfaces. So the gain for the yaw and pitch for the vectored thrust is on 0. So the gyro is disabled for pitch and yaw at this point in time on the vectored thrust nozzle. So let's see what happens. I've got 30% gain. I'm going to rotate the sensor anti-clockwise. So in other words, as if the airplane's yawing off to the left. So in theory, we should have a right rudder correction input. So the servo should move over to the right. So let's see what happens. And there we go, the servo's correcting to the right. In other words, putting in right rudder. Now you notice the yaw servo's not moving because we've got the gain for the vectored thrust on 0, which means disabled. And obviously if we go in the other direction, the servo should respond in the other direction as well. So if the whole aircraft moves or yaws across to the right clockwise, in the clockwise direction, the rudder's trying to put in the opposite command. So it's putting in left rudder to try and turn the model back to the straight line position. So as far as we're concerned, the rudder is working correctly. Now let's double check the ailerons. So if I tilt, say, let's put in a nose down command with the gyro. So if we tilt the nose down, or say the wind blows the nose down or whatever, we should get an up elevator input. So remember, up elevator is servos moving up. So let's pitch the gyro downwards. So the front of the gyro will be pitched down and the back of the gyro will be pitched up. Let's see what happens. And there you go. Both elevator servos are moving up. And if I go in the opposite direction, they should move the opposite direction as well. Too easy. So the gyro sense for the elevator servos and the rudder servos is working 100%. Now, let's reduce the gain to 0. So for the elevator and rudder. So now you can see I'm moving the sensor. We've got no gyro gain on any of the axes. So basically the gyro is disabled. But now I'm going to dial in some gyro gain for the vectored thrust nozzle. So I'll put in, say, I don't know, put in about 30% as well. So this is only for the vectored thrust nozzle, not for the flight surfaces. So remember, I've got 0 gain now on the flight surfaces. So we've got pitch and yaw. So there's the yaw. I'm just moving my rudder stick. So I got yaw and pitch. So let's have a look at what happens when I move the gyro. So now remember, if we turn the gyro sensor anti-clockwise, remember we're getting a right servo correction. So basically the yaw servo should do the same thing. So if the model yaws, not tilts. If the model yaws, say, to the left, in other words, the gyro sensor is going to rotate anti-clockwise, the nozzle on the aircraft, the vectored thrust nozzle, has to correct by pointing to the right as viewed from the rear. So the nozzle will actually rotate around in this direction. So let's rotate the rudder. So in theory, this servo should also move to the right when we rotate this anti-clockwise. No different to what the rudder servo was doing earlier. So let's try it. Let's rotate it. I'll just move it slowly. And you'll notice the yaw servo is actually following our input, but in the opposite direction because it's trying to correct the aircraft. Bring it back, and there it goes. And if we obviously go in the other direction, it corrects in the opposite direction. Okay, let's have a look at the pitch. Oops, I just bumped the camera there. So let's assume the nose of the aircraft, say, pitches up. So you're flying along, doing some 3D maneuver. The aircraft pitches up on the nose. So in other words, this gyro sensor, the front of the gyro sensor is going to pitch up. So if I tilt the gyro sensor up at the front and down at the rear, let's see what happens to the pitch servo. Now the pitch servo is moving down. So remember what we said earlier, the nozzle will be pointing down when this is pointing down and up when this is pointing up. So you can imagine the nose is pointing up. So as the nose points up, the gyro is going to move up like it is now. However, it's going to adjust the nozzle so it points down. So basically it's going to try and push the tail back up, which in effect pushes the nose down. So again, this is also working in the correct direction. And obviously if I go the other way, if I go nose down, so that's a nose down situation, the nozzle is now going to be pointing up to try and push the nose up. So it's going to push the tail down, nose up. Okay, so that looks good. It looks like they're pivoting in the right direction. So I'll just reset those back to neutral. Now I'm going to dial in some gain as well on the back to the flight surfaces. Let's put in, say about the same, 30% gain. So now all the servos pictured in the screen should move. So again, let's try moving the gyro sensor, say rotate it or yaw it to the left or anti-clockwise. Both of these servos should move to the right. And there you have it. They're both correcting in the right direction. There's a bit of vibration in that because I'm not moving the sensor that smoothly. Let's try the pitch or elevator axis. So let's pitch the nose up. So remember, nose up, we need elevator down. So these guys should move down, as well as the pitch control on the thrust vectored nozzle should also point down. So let's pitch the nose up. So I'm going to move the front of the sensor upwards. There you have it. Both elevator servos are moving down, indicating down elevator command. So they're going to try and push the tail up. Same with the vectored thrust nozzle. It's going to be pointing downwards to try and push the tail back up to correct the current attitude. And obviously if we go in the other direction, it does the same thing. So there you have it. Vectored thrust setup. So I suppose the main takeaway from this is the fact that the mixing is done in the radio. So you've got to set that up first before you enter the setup assistant. So a lot of people get caught out by that. They think that the Mercury or the competition or the Royal does the actual mixing, but it doesn't. And it's the same for a Tailoron or Elevon setup on an aircraft. So a lot of people might have, say, an aircraft like some of the jets will have split tail. So basically you can use it as an aileron or an elevator. And sometimes they might do that with a flick of a switch or a flight mode. And in those situations, it's really no different to setting it up with a vectored thrust. You're basically using those servos in different directions. So when you go through the setup assistant, you teach it in the right way, providing the mix is done in the radio, it should all work fine. And I might even do the next video on a typical Elevon or Tailoron setup on an aircraft, just so I can step through it with some people. If they watch this video and say my previous video, they should get a really good understanding on how to set it up. Okay, so actually one other thing, I might just switch back to the course screen because I want to show you something that changes as far as the nomenclature is concerned. In other words, the text that when you assign the various flight surfaces, there's some change in the text when you use the setup assistant. Okay, so just stand by while I switch screens. Okay, so we're back to the course screen, and what I really wanted to show you is, let's go back to the main screen. I want to go into the Mercury menu, or Mercury's menu, and I want to show you a couple of parameters that are different compared to, say, my previous videos. So if we have a look at, say, the mapping, so just go over to, or even the input mapping, you notice we have aileron right, left, and the third aileron, aileron C, similar with the elevator. However, you notice with the elevator, we've got, oops, I went too far, elevator right, elevator left. Instead of elevator C, you'll notice the setup assistant has automatically relabeled that as VT pitch. So vectored thrust pitch, then we've got rudder, and then we've got vectored thrust yaw instead of rudder B. So that's something you can't change. That's done with the setup assistant. So when you select a vectored thrust model, it automatically populates that in the input mapping screens. And the same goes for, I think, the gains. No, actually not in the gains for the mapping, but in the output mapping from memory. So if we scroll through the different ports on the Mercury, you'll notice here it's automatically populated vectored thrust yaw for the actual text. So that's something you can't select normally, so that can only be done through the setup assistant. So that's why I recommend you use a setup assistant whenever you use a vectored thrust model, because otherwise you can't actually set that up manually, so to speak. And of course, if we go back all the way to all the first couple of ports, so we'll have aileron port, aileron right, and then B is elevator right, and then C's rudder from memory, and then we'll have vectored thrust pitch, which is port D, which is where I had the pitch servo plugged in. So yeah, just something to be aware of. It's just something that's handy, I suppose, when you're programming and plugging things in, because it's referred to that, in the screen of the OLED display as well. You'll see that text come up. And yeah, that's pretty much it. All right, so hopefully you've learnt a little bit on this video, or from this video. And yeah, stay tuned. Next video, if someone can twist my hand, maybe I'll do a, keep it short, but I'll do a video on how to set up Tailorons on an aircraft, or Elevons, whatever you like to call them. Okay, stay tuned to my channel, and I'll catch you all on the next video. Thank you.